This example uses a different technique to start off with, but ultimately it will be the same change of variable. What we're going to do is look at the linear expression we have at the start, 2x plus 1, and then we have the square root of x plus 4. We can see that if you differentiate x plus 4, as we've done before, we'd get 1. But outside that square root sign, we've got 2x plus 1. So what we do here is similar as before. We let u equal what is inside that square root sign. U will equal x plus 4. But unlike the other questions, this is where we do a little bit of manipulation. If u equals x plus 4, rearranging that, we get x is equal to u minus 4. The other thing we can see is if we differentiate u with respect to x, du dx, we will get 1. So let's have a go now at doing some substitution and see what happens. What we have at the start is 2x plus 1. So we've got a 2 times x. Now what we've done is we have just found that x is equal to u minus 4. So what I'm going to do is substitute the u minus 4 where x is. So we've got 2 times u minus 4 plus 1. I'm going to write that in brackets to be mathematically correct. All times the square root of x plus 4. Now, x plus 4 we have got is equal to u. So there becomes a straightforward substitution. Our problem here is, though, we now have everything in terms of u, and we've got dx. That's the wrong variable. We need to have du there. But what we're going to do is use a trick. You know, 1 times anything is itself. So we're going to go integral of 2u minus 8 plus 1 times the square root of u times 1. Because I'm multiplying by 1, I'm not changing the problem because 1 times anything is itself. So integral 2u minus 8 plus 1 becomes 2u minus 7 times u to the power of 1/2. Now we've multiplied by 1, so we haven't changed the problem, but what we do know is that du dx is equal to 1. So we're going to substitute du dx where the 1 is. So we get du dx times dx. In effect, the dx's have cancelled. So we're now going to multiply out our brackets. We've got 2u times u to the power of 1/2. That will give us 2u to the 3 on 2, and we have minus 7 times u to the 1/2. And that is du. Now we have everything in this problem in terms of u, so now we will antiderive each term separately. So we have 2u, add 1 to 3 on 2, you get 5 on 2, and divide by 5 on 2. Minus 7u, half plus 1 becomes 3 on 2, and divide by 3 on 2 plus c. Turn it upside down and multiply. We get 4/5 u to the 5 on 2 minus, again, turn the fraction on the bottom line upside down and multiply. We get 14 on 3 u to the 3 on 2 plus c. U, we know, is equal to x plus 4, so we get 4/5 x plus 4 to the power of 5 on 2 minus 14 on 3 x plus 4 to the power of 3 on 2 plus c.